is that I've been working with Krüger-Veolia, and then in collaboration with the DTU Compute, where I've been writing, but also DTU Environment. And the project we've been working on is called Smart Control of Wastewater Treatment Aeration. And that is what I'll also talk a bit about now. So, yeah, I actually wanted to change slide here. Let me just, okay, now I think it's working right. Do you see a new slide? Sorry.
It's a very nice first slide, but we
okay,
we
that was what I was fearing. Why doesn't it? Let me just try one more time. Okay, now I think it's changed, right?
It's changing now. Yes.
Okay, yeah, sorry about that. So what you see here is, as many of you might recognize, a wastewater treatment plant, and more specifically the largest treatment plant in Denmark, which serves a large amount of the Copenhagen area. So basically this one treats all the water that we use in households, in industry, and also in the runoff water from streets and from surfaces when it's raining. But this one also uses a lot of electricity, as all wastewater treatment plants they do. Basically 1% of the total electricity consumption in Denmark goes to wastewater treatment. And if we look a bit more into this, then there is one process, namely the aeration, which literature agrees is the one that uses the most electricity at a wastewater treatment plant. About 40 to 75%, depending on the specific equipment at the plant and other factors, goes to aeration. And now you might be asking, what is aeration? What does it do? And basically, here is an example from another small Danish plant. Basically, aeration is added to reduce different nutrient concentrations in the wastewater. So actually to activate some biological processes and thereby reduce some different nutrient concentrations in the wastewater. So what you see here in the picture is that the ammonium in the top and nitrate in the bottom, and then the blue areas is when aeration is on, and the gray areas is when aeration is off. And then we have this behavior where ammonium is reduced to nitrate, and nitrate is then further reduced and removed, thereby removed from the wastewater as nitrogen gas. And this process here is one of the essential parts of wastewater treatment, which we have been trying to control in this project. So the way we do it is that we have made a relatively simple data-driven model of the wastewater treatment plant, which can be adapted to different plants. And that model is then generating future scenarios, or can generate future scenarios. So how will the nutrient concentrations develop over time if we aerate in different patterns or different ways? And then we use this model to optimize ahead, and then we send some control signals to the process, which then in return gives us some new measurements. We have some sensors equipped in the process, which gives some new measurements back to the model-based optimizers. Then we can recalibrate the model and so on. And that is what is called model predictive control, or MPC, which we have been developing. And just to show you how this can look again for ammonium and nitrate, then here we have just one picture where we have now optimized about 3 hours ahead. So we want to keep the mean ammonium concentration and the mean nitrate concentration below these dashed or dotted black lines. And here we see the aeration as the blue in the back, and then the gray areas is the non-aeration, the aerated times. And then we have a prediction where we have optimized, and we think this is the best way to do it if we just want to keep ammonium below the line on average. And then when it's running, then it can look something like this. So yeah, now we see that we are optimizing all the time whenever new measurements becomes available, and so on. And that is the idea with model predictive control, that we then optimize, as I said, whenever we get new measurements available. And now you might be asking, why is this useful, and why has it anything to do with smart aeration or smart control? And the idea here is now that using these principles, or this principle, we can actually include other inputs, such as electricity prices. So we have made an objective function which considers both the electricity cost, but also there is also a tax on the effluent concentrations that are discharged. So we have included the electricity day-ahead electricity prices in the optimization of the wastewater treatment aeration. And what you see in the picture now is an example. It's 50 random days from 2019 day-ahead prices. And then one example day that is highlighted. I'll come back to that in a moment. But this is 50 random days of electricity prices with some diurnal variation, and there are also some few negative hours and so on. And then if you pay closer attention to the example day, then you see that there is a cheap period in the beginning of the day, and then some expensive periods later on, from approximately 8 o'clock until midnight. And then using this example day, now I will show you how we have optimized again 24 hours ahead. So now this is a larger horizon. We look ahead for the model predictive control, but still we use this principle with optimizing time ahead. So what you see here is that we like to aerate a lot in the beginning, and that is, of course, if you remember, that was where we had the cheap electricity prices, and then we save a lot of electricity later on. So basically we want to get low ammonium concentrations in the beginning, and then accept that the nitrate concentrations become higher. And then, as time goes on, then we want to use less aeration. So this is basically a way to control it in the cheapest possible way. And if we compare to just a scenario where we have some constant electricity prices, then and optimize in the same way as before, then we want to do something like this new plot shown to the right. And what is interesting here is that if we compare these two scenarios, then we actually see that the one to the left, yes, that one uses actually 6 percentage points more aeration as compared to the one to the right. But even though it uses 6 percentage points more aeration or more electricity, then it's actually 13% cheaper as compared to the one to the right. And now you might say that this is of course only for this quite extreme example day. So we did this same experiment for all the 50 different days, and we ended up with something looking like this, shown as some box plots, where the one to the left, scenario A, that is the one where we use the flexible or the varying electricity prices, and that one is in this, for all these days it's about 3.5% cheaper as compared to B, which is the one with the constant electricity price. But still, both of these are about 10% cheaper, or sorry, A is 12 and B is 9% cheaper as compared to the rule-based control, which is the one that was already installed at the Nørresnede wastewater treatment plant. And so, and then we also looked into, is there a correlation between the within day maximum price difference and the difference between these scenarios A and B? And we saw that if there is large price differences during a day, then the potential for saving money if you use variable electricity prices as compared to constant electricity prices, that potential is higher. And we have tried this full scale on actually 4 different plants now, and we have been running for a bit more than 1,000 hours. But mainly the 2 main plants we have been testing on is Vamdrup wastewater treatment plant and Melby wastewater treatment plant, which is 2 smaller plants, one in Jutland and one in Northern Zealand. And finally, the conclusion here is that we found it is possible to use model predictive control for minimizing the costs. It is cheaper compared to the current control that they're using, at least in the test cases we have seen. It is the feasibility depend on the markets that we are looking into, and also primarily within day variations. And finally, we have been testing full scale now for some time, but we need some more tests, in particular to conclude whether or how large the potential for saving is, and also in general how well it works on longer time horizons. So thank you. That was my 10 minutes. And if you have any questions that you do not have time to ask now, then feel free to write me on email or contact me on LinkedIn.